All right. Sorry for the delay. Sorry for the delay, ladies and gentlemen. I had a issue with my headset, so unfortunately it caused me to be late for the webinar. So I apologize. Appreciate you guys hanging in there. My name is Rob Romanowski. I am the Director of Sales Operations with 3HTI, and today we're going to take a look at Onshape, which is a new concept in CAD. Well, maybe not really a newer concept, but it is the only 100% cloud CAD system on the market today. And in the subject line of the email that I had sent out for this webinar, I wrote the future of CAD and PDM. And what we're going to look at is how this modern design platform is a completely different CAD system with product data management automatically built in and integrated within it. And Onshape was created by two former SolidWorks CEOs. So for all you SolidWorks fans out there, you'll be happy to know that John Hirschtick and John McEleney both created Onshape. And in an effort to bring CAD to the next level, their focus was to have a powerful CAD system, 100% in the cloud, in order to allow changes to be made automatically, even if two people are working on the same model at the same time. SolidWorks has a reputation of crashing quite a bit, so I think that was something that they wanted to find a way to overcome with that software. And unfortunately, we haven't seen much from SolidWorks in the past several years as far as updates to their new releases. And we're hearing from SolidWorks users that they're not really necessarily happy about that. But anyway, we're here to talk more about Onshape. So if I can get to the next slide here. So what we're going to do is we're going to take a look at this specifically as if this was a whiteboard. I mean, looking at how Onshape does data management. When we're talking about a concurrent design process, we're thinking about one or more people that are part of the design process. And these people don't have to be just internal people. They can be part of your external development team, part of the supply chain. They could be outside vendors. They could be outside mold design house or sheet metal design house. These are all people that are part of your concurrent design process. So I went the wrong way. There we go. So everything below this line, this dashed line, are going to be items that are going to get in the way of concurrent design. And because software tools that are installed in your computer are version-centric, you will need everybody to be on the same design platform internally and externally and have the same version of software to be able to communicate effectively. Or else it's going to be difficult to manage the rate of change that's occurring. So you end up having to translate files that you end up with and end up getting copies of files floating around. So let's talk about these copies of files for a little bit. How do people try to conduct concurrent engineering and concurrent design when working with files? So what they'll do is they'll email files back and forth. They'll use a system like OneDrive or Google Drive or Dropbox to share these files, which is pretty easy to share files back and forth, but still there are only copies of files. Only one person at a time can work with these. And they're locked as soon as somebody tries to open the document. Or with Dropbox, as I've seen, is you can end up with a conflicted copy. So you have copies of files and it's uncertain as to which one's the right one. So how do companies deal with this? Well, one of the ways they deal with it is they invest in local file servers. Or they'll invest in a PDM system or a PLM system to manage the rate of change and protect the files from being overwritten improperly. And they'll build in workflows. But what's interesting is that this can create even more copies of files. So for example, PLM systems can use a check-in and check-out method. And when you check a file out, it is downloaded and copied to your local desktop where you can work on it. But the file in the PLM system is locked in the cloud. Nobody can access it or even view it until you check it back in. But when you check that file back in, you are still going to keep a copy on your computer. Most likely it's going to be in your downloaded files, but it's going to keep that copy on your computer. And you need to keep that in mind because, say, in 2 weeks or a week or whenever, you have to access that file again and you bring it in to your computer to make changes, you don't want to make the mistake and update the wrong file if somebody else has worked on it. So that can create an issue. So anyway, people are also looking at business solutions like SharePoint and business accounts on Google Drive to move files and processes into the cloud. But still, you're not truly working in the cloud. You're actually working on a synchronized copy that's connected to your computer. So it's the same as a PDM or a PLM system, but you have a lot less control. And these systems will constrain the processes that people want today. And what they want to do is work faster and work on multiple products all at the same time. So in this illustration, we have 3 engineers on the screen. And the first engineer is a design engineer. And he or she starts the product development process. And they pass everything downstream to the next engineer for the assembly design process. And then to the third engineer who gets the assembly and does their work. The issue is that only one person at a time can work on the assembly because that's how file-based systems operate. Only one person at a time can work on the file. The longer it takes for everyone to get the files to the third engineer or the last engineer, not only can that delay the deadline, but if there's an issue, it's going to go all the way back to the beginning, and the file or the product is going to need to be modified, and any change in that process is going to be costly, not just because of additional engineering hours, but lost revenue costs associated with missing deadlines or delays in getting your product out the door. And this metric is called cost of change. There's another metric called cost of delay, and in that metric, what will happen is you'll find problems later in the design process, and that happens when deadlines are missed and products are delivered late. The way that Onshape is architected, you'll see everything is in one place. There's never a copy of a file that goes from the server to your hard drive where you have to work on it. Everything is done in the cloud. So this is a database-driven approach where multiple people can be in the same assembly or part at the same time and have safety and control. So Onshape runs in this unified cloud platform known as the Atlas platform. And everything you need for product development is in one place with a database-driven approach where multiple people can be in the same assembly or the same part. So this is actually a new 3D CAD system. It's a unified solution to solve the problem of passing files back and forth. It's the easiest way to share products and knowledge without having to take it from the cloud or take it from your computer or giving somebody else access. The solution was not building a PLM system in the cloud. Onshape had to create an entirely new CAD system to be able to do this. And this CAD system was building this modern architecture that's supporting concurrent design. Now, because this is a cloud solution unified, we can do many other things that are innovative. For example, like data management. Data management becomes very easy to accomplish for one reason. And also, you're not paying the IT tax to maintain your own servers and keep those servers up to date. So there's no monthly maintenance or anything else that's needed. So you're going to save a lot of costs from an IT standpoint. There's also a lot less data traffic, and files are not passing back and forth. You also have the ability to branch off and explore alternative timelines, as you see here on the right side of the slide, with a infinite amount of change comparison available at your fingertips because Onshape records everything as a transaction in the system. So you can see exactly who made changes and when. And this is probably the easiest way to share product knowledge. So there's many other capabilities that Onshape has, including a bill of materials, task management. We can get that into more detail if necessary. If you want a customized presentation, we can do that. But understand that a unified cloud solution will allow collaboration in a parallel fashion, and it allows you to work on any device that you want to. So you can work from a Windows-based system, iPhone, iPad, Chromebook, doesn't matter. Onshape allows one person to use a Windows-based computer and another person to use maybe a Mac-based or an iPhone and access the system or access the files at the same time. And one of the questions that frequently comes up in these webinars is, well, if two people make changes at the same time, how does it record the change? Well, the system will just pick one over the other as far as who made the change before the other person. And as I showed in the previous slide on the right-hand side, you can see exactly who made the change and when. So this provides a reduction in infrastructure costs because it's 100% cloud-based technology. So with that, what I'm going to do is I'm going to pass everything over to, or actually I'm going to stop sharing my screen because I can't pass control because this is not GoToWebinar. But on Zoom, I will allow Bill Stickney to take control and share the screen. Bill is a industry veteran. He's been with us at 3HTI probably for about, what, 15 years, Bill?
Yeah, about that.
And long time with Laird Technologies, has seen and used a lot of different CAD systems. He's also a FEA and CFD expert. So Bill's really knowledgeable, and one of the things that we're excited about with Onshape here at 3HTI is because Bill likes it. So that's kind of the litmus test. If Bill likes it and he thinks it's a viable system, then we get excited about it. So Bill, feel free to demo away.
Very good. One other thing I've been known to do is software development. And I can tell you that the first thing, or the first week or so in computer science school, you learn that the objective of all computer software is to store every piece of information exactly once. So if you change it where it's stored, it changes it everywhere it's used. Parametric modeling kind of does that, but we do have the problem with multiple copies. Onshape takes care of that because it's stored in the cloud system. There is exactly one copy of everything. And if anybody changes it, it changes everywhere for everybody. Now, I have Onshape open. It opens, but I think you can use most any browser, and including, I might add, browsers on Macs and tablets and phones and things like that. If you've got a browser, you can basically run this. Interestingly, when I opened this up, I got a message over here. It says, what's new in Onshape? So functionality has been added since I last signed in. I signed in this morning. So between about 9 this morning and noon, they updated their software. And they have updated any data that was necessary to update. They've already done. There is no versioning in Onshape. It is always the current version. And in the background, they do, in fact, update and modify data sometimes if necessary. They do updates.
So, Bill, you don't need to log in and download the latest version of software. It just happens automatically.
Yep, it's right there. You just log in, you're going.
And that's another thing to point out is that with Onshape, there's nothing to download. You just access it right in the cloud. And sometimes downloading software can be a mess. I mean, I talk to people who have used SolidWorks, not to beat up on SolidWorks all day, but SolidWorks says it's supposed to be 40 minutes to download the software. And I've had people tell me if you get it done in less than 2 hours or around 2 hours, you're doing great. Because there can be a lot of issues. It's almost like a snowflake. Like each download of SolidWorks is like a snowflake, so it could be temperamental to your computer. So anyway, I'll let you continue, Bill.
Yeah, well, a lot of the problem is keeping everybody on the same version. That's a bit of a challenge sometimes. So I don't know what they've added. They put these updates in roughly every 3 weeks, and we'll see what they've added here. Well, we got better markup comments, got better explode line formats, something new in section views. As I say, I haven't even seen this yet, so I'm not sure what they got here. Apparently, they've added some capability to the mobile device and so on. I'm not going to go through this in detail. I'm just showing you that they keep updating this, and it's getting better from every 3 weeks. And it's already pretty good. So I'm going to show you some things here. Now understand this is a parametric modeler. So it has got some, from a user point of view, some similarities between Creo, Pro Engineer, SolidWorks, CATIA. They all use history-based parametric modelers, and this does too. So if you're familiar with those products, you won't have too much trouble learning this. But this does some other stuff. I'm going to open this guy here. This is a weldment that I designed. It's just a sample. And right now I'm looking at a finished product, but what I actually want to look at is the Part Studio here. So a Part Studio allows you to create geometry, and typically solid geometry. It does, by the way, a very nice job with sheet metal also, although we're not going to look at that today. So in this design studio, I designed 3 parts that are in fact part of the same weldment. So they are designed concurrently and they have common references and they can reference each other as well. So if I make changes to dimensions in here, it may affect all 3 simultaneously, but that's the intent here. But what's interesting here is if we go into the version history, I did a branch. Now this is something that is kind of unique to Onshape in that I can go off on a tangent here and try something different, maybe just because I'm trying a different design, or in this case, I'm actually doing some machining operations. So I'm using this as a method to capture both the as welded state and then the finish machine state, all in the same model. So I have a state here for my weldment not machined. And if I were to click on this, it would show up and you see there's no cuts or holes in there. And then after I branched, I put machining operations in, and now I have a finished product looks like this with all that stuff in it. So this is not 3D, this is like 4D, because I'm able to show my design in different states or different times, if you will, pseudo time, I guess. So this branching is quite powerful. Another use is just to try different ideas out. You know, I'm just going to add some material over here and put a cut there and then take it down and let the machining guys look at it and see if they like it. And if they don't, I'll try something different. And you can keep doing that pretty much as long as you want. So that's one of the very powerful capabilities of Onshape. And when you go to the assembly, see this is not an assembly at this stage. These are parts. They happen to be in the same space and they can be related to each other, but they're actually not assembled. What I did do here though is, let me see, for example, I'll hide these parts here. Here's my rib part. So you can work on these parts kind of separately by hiding the ones you're not interested in at the moment. What you'll note here also is there's a little symbol down here. That is called a mate connector. And I have the option of defining these in the part creation, which is done here. And then those are used to assemble parts together. They're basically coordinate systems. But what they allow you to do is when you go into an assembly, you can just snap stuff together. It is very, very reliable. And this is a problem that we understand is a big problem in SolidWorks, is that their assemblies are difficult and not terribly reliable. But these are very reliable because of this mate connector business. So I'll show you the assembly here. Here's my assembly. And I brought these things in and just snapped them together like, like Lego bricks, basically. And this also, if I believe I have this set right, yeah. Let's try this. All right, so there is the assembled weldment with no machining part cuts, and then here's the finished product up here. So I was able to carry that through to the assembly level as well. So you can have assemblies in different states. Quite a powerful thing, actually. Would also point out that in the assembly process, we have, in addition to using make connections, you can also use them where they are partially constrained, so we can have mechanisms. So we could, for example, have things that are rotating or translating, sliding axially, pivoting about a ball, that sort of thing. So we have full functionality on that kind of stuff. All right, so let's move on to something else. I want to close this now. And I want to show you another technique that we can use for okay, it's in here, I think. Yes, let's grab this guy here. This is part of a solenoid valve. This would be like the top of the solenoid valve. That doesn't look very good. Let's do this. We'll go over here and look at the casting. So I made this this casting model. This happens to be the only one in this design studio. Typically you're gonna have more than one part, but you could have one. Depends on how your data is organized. So the intent here was I wanted this to represent a raw casting. So this might be a sand casting and possibly a die casting, I'm not sure. The parting edge is right here. So we have a core and a top. And you'll note that I have added mate connectors out here where the bolts go, and other mate connectors on the bottom and the top where the mating parts go, because they're consistently in the same location. So this makes it pretty easy when you go to do the assembly. But what's interesting here is I took this and using a different technique. This is using a technique which is, well, it is technically inheritance, although I don't think it's actually called that. No, that's not it. Not important. What I did here was I inherited this casting right here. Derived is the term they use in Onshape. So this is derived from the casting model. So I now have a copy of that. This does not have a model tree at this point, but now I'm going to add additional features to it. So I've gone in here and I have drilled holes, or probably bored them out. They may have been cast. Machined the bottom here, put threads in up here, and I now have a fully machined part, and this can be now released to manufacturing. Now, of course, you can make drawings of all this stuff. You could make a drawing of this real quick here. I'll show you how that works. You insert a new element. Element in this case would be a drawing. And let's see, I guess we'll use that one. This was designed in inches. I think that's good. So I now created a new drawing, and I have to go out and grab something to put in the drawing. So here is my machined bonnet right here. And that's what we're going to add to the drawing. So now I can put in a view. So here's a view. And I could project more views off of that. I could come up here and project a view. You can cut cross sections in these too if you want. Let me try that. Try a section view. And I think we would do it like this. Nope, I'm sorry, that's not it. That's for a broken out section. That's not what I was trying to do. Don't want to belabor this, but suffice it to say, in this process here, we'll try projecting a view. And in this case here, I will see if I can put a section in it. All right, well, that's There's a non-projected view. That's kind of neat. Anyway, you can add dimensions to all these and make full drawings. Dimensions would be something like this. Come in here. Dimensions are actually not captured from the solid model. You would add them here. And there we go. We got our drawing. All right, so I want to go back and show you another aspect of this too. And this is kind of neat here. I took my bonnet part here and made a variation on it, which is that one. No, it's this one here. What I did was I took my bonnet and I made a version of it. It's hidden right there. That's why we're not seeing it. There we go. So I made a version of this where I plugged up a bunch of holes and then inserted it in this nest block and then did a Boolean operation to subtract material with clearance. So now I have taken my machined part and converted it into a nest. And in this case, this nest might be used for machining. So we would take this thing and plug it in here, and it would hold it in position while we go in and then add our cuts on the bottom and our holes or whatever we need to do. This this is actually done frequently on very complicated parts with organic shapes where we just don't have anything you really can grab a hold of easily. So that's one of the techniques here, and this was done with the inheritance operation or the derive. Okay, so we're good with that. Let's move on to something different here. I'll close that guy, and we could go to an assembly. So I'm going to go into my valve body here, and we'll show a little bit of assembly. So this is the bottom half of that same valve. And this was made out of a casting also. Interestingly here, you'll see that on the inside, we have some fairly complicated geometry. We have this, this groove that kind of spirals downward and gets deeper as you go. We also have the slanted bottom here. So this is starting to get a little complex. But Onshape was able to handle this pretty well. They've got a fairly good library of solid tools. One of the things they do have is the ability to create surfaces. This is a reference surface here. So we'll turn that off. And you see here what I did was I created that surface and then extruded up to it. So it is a depth reference for the extrusion. Then I can hide it later. So you can use all kind of curves and surfaces for construction. It works nicely. The inside cut here was done with a Loft feature. That is, in other tools, that would be called probably a swept blend or perhaps a blend. I think it may be also called a Loft in some tools. But it allows you to transition from one cross-section to another following a path. In this case, it was a circular path. So fairly powerful stuff. But let's make an assembly out of this. This would be more interesting. So we'll go in and create a new assembly. And my first item will be the valve body. So we assemble that. And if I want it to be in a particular location, I can do this. See, right now it's just floating in there, but this fastens it. So I can go from this mate connector to the center of the part here, and that should locate it or lock it in. All right, well, that's not doing quite what I expected. That's not important though, but let's assemble the next part in here. We'll do an insert. Now, in this case, I want a gasket. The gasket is in a different document, I believe. Now, let's do the diaphragm. That's already here. So we'll grab this guy here and assemble it. So I can just park it in there for now. Now, this would be a nuisance to assemble in some tools because you would have to go in and start picking cylinders and planes and things like that. But I have pre-made mate connectors here. So when I go to assemble this, what I got to do is grab that mate connector and this mate connector, and that should assemble it. And it's done. Looks like the center of it got loose. I'm not sure why that is, but the point here is that you can assemble these things pretty easily by all right, I'll tell you what, we won't worry about that part. Let's just hide that for now. Haven't worked on these models lately. All right, so we could do another assembly. Let's go in here and we'll insert from the from a different document. Recently opened. Here's my valve bonnet. This goes on the top. And we want the machined version for this. So here is my bonnet machined. Should be that guy, I think. All right, so we brought that in. And now we do the same thing again with the mate connectors. We grab this guy here, grab a mate connector there, and a mate connector here. In this case, it's the top of the gasket, and it's done. Looks like we got two bonnets. We'll get rid of one of them. Down there at the bottom. Oh, wrong one. That's okay. I got an undo button. So we'll just hide this one for now.
I love undo buttons.
Yeah, it actually works good here. And this is interesting. In Onshape, the history, I guess this is the history here. Nope, that's not it. That's a version control. Yeah, this is the history here. It shows a lot of detail. So see right here, here's all the stuff we just did. So it's not quite every keystroke, but it's pretty much every time you click on the checkbox, it records what you did, and it keeps this forever, basically. So you can go back and you can undo stuff, you know, back till weeks earlier, possibly. And
interesting.
Yeah. And you can also save versions, which I did here, and let me show you that again. See, I have a version here where my valve is closed, and then I have another one here where the valve is open. That was done with a family table. Again, using this time element to show my design in different states. But the nice thing with these connectors is when I go to put bolts in here, for example, I just snap them in. So it's just like putting Lego bricks together. The only thing you got to do is create these little mate connectors where you know you're going to need them anyway. Or it is also possible, if you've got nice simple shapes like cylinders and squares and things, it will create mate connectors on the fly. But the nice thing is they are extremely reliable because they're based on whatever geometry you referenced them to when they were created, and they don't change. Things do not get away from you in one simple operation and you're assembled. So I rather like that aspect of Onshape. Did a nice job there. Anyway, so I've shown drawings and assemblies and branching. I don't think we need to show a whole lot else right now, Rob. I think we're getting about out of time. Have any questions?
If anybody has any questions or wants to see anything specific, please type that into the Q&A section or the chat, and we will gladly have Bill demonstrate something a little more specific for you if you want. But once again, I mean, as Bill showed with all the the history that's maintained in the cloud. It's easily accessible. You can see whoever makes changes, when those changes are made, and I think it's pretty amazing. You can go back to an earlier date, and that'll be the version that you start working with, which is pretty cool if you want to save another file and copy what you've done. Take basically an earlier version and then make a separate version of that, copy a different file or whatever. It's definitely a lot of really cool capabilities with this. And once again, going back to the data management aspect of it, everything is in the cloud and everything is updated automatically. And you know that you're always working with the latest file, which is pretty cool. So,
one other thing I want to mention, Rob. This button right up here is very important. This is a share button.
mm-hmm.
If I click on the share button, I can now go in here and send an email to people that I have on my list. And they will get an email that says you've received a new design. They can open Onshape. And by the way, they do not need to install anything or have any kind of a special computer to do that. So I could send this, to a machine shop or something, and they can open it up on whatever the computer they have, and they will have access to it. We could give them access to edit it, but maybe not. Maybe we'll just view it. So they can go in and take measurements off it and decide how they're going to manufacture it, or if they want changes made. So that's rather nice. Other tools require you in some cases to load special viewing programs, things like that. This does not require it. You can open it on almost anything you own.
Yeah, no need to convert it to a step file or a neutral file.
Yeah, you don't want to do that because that breaks associativity. I mean, you can do it if you need to send it to a printer and you have to have a step file, you can do it. And you can bring objects like that in, but to maintain associativity, you don't want to do that unless you have to.
Yeah, SolidWorks is notorious for losing data when their files have to be converted or translated. Good stuff. So that's going to wrap everything up for the webinar. I'm actually going to take control here for one last slide. So if you need to contact us, you can give us a call at 866-624-3HTI. You can email us at info@3hti.com, or you can contact me directly, or you could just respond to the email invitations that we sent out to you, because anybody who responds to those emails, they come directly to me. So if you have any questions, if you want to see a demo, if you want to go through a trial of Onshape, we're more than happy to help you out with that. So if you have any questions in general about other items, other issues that you're facing within product development, we're pretty good. We've helped a lot of companies. We help a lot of companies be able to manufacture, increase the amount of products that they manufacture on a monthly basis, and also helping them to get these products to market on time, which is huge. So feel free to contact us if you have any questions. I want to thank our audience for being on, and Bill, as always, great job, and thank you for the demo today.
All right, be happy to answer more specific questions if we get some coming up.
Sounds good. Thanks, Bill. Thanks, everyone, for being on. Take care and have a great day.
Bye-bye.